first thing we're asked to do here is find r, make r the subject of this formula. So we've got a is equal to pi r squared. In order to find r, we need to get r on its own, so we're going to divide both sides by pi. Okay, dividing both sides by pi, the left-hand side becomes a over pi, and the right-hand side is just r squared. To find r, then, we now need to square root both sides. The right-hand side becomes just r. The left-hand side, be careful how you write it, becomes the square root of a over pi. So r is equal to the square root of a over pi. Okay. What we're now given is the area of a circle as 14 square centimetres, and we're asked to work out the lower bound for the radius. So we're going to use this formula. First of all, though, we need to find the upper and lower bounds for the area. Now, if something is rounded to 14 square centimetres, but that's to two significant figures, the second significant figure is the units column. So this number has been rounded, or the area has been rounded to the nearest whole number, or to the nearest 1, which means we add and subtract half of 1, always add and subtract half of whatever it's rounded to. We add and subtract half of 1, which is 0.5, to find the upper and lower bounds. In other words, the area of our circle is somewhere between 13.5 centimetres squared and 14.5 centimetres squared. Okay? We're now going to find the lower bound for the radius. So we want to find the minimum possible radius. And the minimum possible radius, using the formula here, is going to be found using the minimum possible value of a. Well, that's 13.5 over pi. Now that, if we work it out on your calculator, comes out as the minimum possible. On my calculator, I get 2.07296, Okay, so that's the absolute minimum possible value for the radius of the circle. Okay, what it now says is give the radius of the circle to an appropriate degree of accuracy. This is quite a common IGCSE question. What we need to do is basically find also the maximum possible value of the radius, which is going to be, instead of using 13.5, using the 14.5. And that, if we work it out, comes out as 2.1483 blah 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 centimeters. So we know for sure that the radius of the circle must be somewhere between 2.07 and 2.14 centimeters. And what we're looking for here is a value that we can give the radius where we can be absolutely sure that we know that the radius is correct. And I find the easiest way to do this is using a table. Okay, so I'm going to make a table with the minimum possible value of r and the maximum possible value of r, the radius. And let's start with rounding perhaps both to about 3 decimal places. So the minimum radius of the circle to 3 decimal places is 2.073, whereas the maximum radius to 3 decimal places is 2.148. So that we know to 3 decimal places the radius is somewhere between these two values. Okay, if we go to 2 decimal places, the minimum radius is 2.07 and the maximum radius is 2.15. So the radius to 2 decimal places is somewhere between those two. If we now go to 1 decimal place, the minimum radius is 2.1. The maximum radius to 2 decimal places is also 2.1. So we can say for sure that the radius of this circle is 2.1 centimeters to 2 decimal places, because if it's anywhere between those two values, it will also round to 2.1 centimeters.